Time travel, the ultimate mystery. It's inspired countless stories, from H.G. Wells' The Time Machine to the mind-bending paradoxes of Back to the Future. But what if time travel isn't just a work of fiction? Could the secret to bending time lie hidden in one of the universe's greatest enigmas, dark matter? Today, we'll explore how this elusive substance could hold the answers to time travel and challenge our understanding of physics, space-time, and reality itself. The elusive nature of dark matter. To understand how dark matter could influence time travel, we need to unravel what dark matter is. Dark matter makes up about 85% of the universe's total mass. But it doesn't emit, absorb, or reflect light, which means it's invisible to even our most sophisticated telescopes. Its presence can only be inferred through its gravitational effects, like the way it holds galaxies together or bends light from distant stars in a phenomenon called gravitational lensing. Scientists believe dark matter interacts with ordinary matter through gravity and potentially other unknown forces. But its exact composition remains one of the biggest mysteries in modern science. Some theories suggest it's made of exotic particles, unlike anything we've ever encountered. Others propose it might exist in massive, undiscovered fields or clumps. Its mysterious nature raises an intriguing possibility. Could dark matter interact with space-time in ways that allow for time travel? How gravity and time are intertwined. Let's take a step back to understand how dark matter might influence time. According to Einstein's theory of general relativity, space and time are not separate entities. They're interwoven into a single fabric called space-time. Massive objects like stars and black holes create dents in this fabric. This distortion of space-time doesn't just affect the path of objects, it also slows down the flow of time. This phenomenon, called gravitational time dilation, means that time passes more slowly in stronger gravitational fields. For example, astronauts on the International Space Station age slightly slower than people on Earth due to the weaker gravitational pull in space. Now imagine if we could amplify this effect. If dark matter has significant gravitational properties, could it create distortions in space-time powerful enough to bend or even reverse the flow of time? The wormhole connection. One of the most exciting theories is that dark matter could help stabilize wormholes. Wormholes are hypothetical tunnels through space-time, connecting two distant points. Picture space-time as a sheet of paper with two dots drawn far apart. If you fold the paper so the dots touch, a wormhole would act as a tunnel connecting them, allowing for instantaneous travel. But wormholes aren't just about moving through space. They could also connect different points in time. The problem? Wormholes are incredibly unstable. They would collapse almost instantly without an external force to hold them open. This is where dark matter could come in. With its gravitational properties, or perhaps some yet-to-be-discovered interaction with space-time, dark matter might provide the stability needed to create traversable wormholes. Could dark matter be the missing ingredient in creating stable, usable time portals? Dark matter and black hole-like effects. Dark matter might also replicate the extreme conditions found near black holes. Black holes warp space-time so intensely that they create regions of extreme gravitational time dilation. Time slows dramatically near a black hole's event horizon, where the pull of gravity is so strong that not even light can escape. In theory, if dark matter could create similar localized distortions in space-time, it might allow us to manipulate the flow of time, slowing it down, speeding it up, or even reversing it. But how could we achieve this? Can we manipulate dark matter? Here lies the challenge. Dark matter is incredibly difficult to study, let alone manipulate. Scientists have theorized that dark matter might not be evenly distributed throughout the universe. Instead, it could exist in concentrated clumps or fields that remain undetected. If we could locate and harness these clumps, we might be able to create localized gravitational anomalies. Think of it like bending light through a lens, but on a cosmic scale, bending time and space itself. But this would require technology and understanding far beyond our current capabilities. Closed time-like curves, a time travel loop? Another fascinating concept in theoretical physics is the idea of closed time-like curves, or CTCs. These are loops in space-time that theoretically allow an object to travel back to its own past. Imagine a train track shaped like a loop that lets a train return to its starting point. CTCs are permitted by general relativity under certain extreme conditions, such as near-rotating black holes or in regions of intense space-time curvature. Could dark matter provide the energy densities or gravitational effects needed to create CTCs? If so, we might have a theoretical framework for backward time travel. The paradoxes of time travel. Even if dark matter enables time travel, it raises profound questions. What about causality, the principle that cause precedes effect? Time travel could lead to paradoxes, like the famous grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, would you still exist? Physicists have proposed potential solutions to such paradoxes, including the idea of parallel timelines or multiverses. But these theories remain speculative. And let's not forget the potential risks of manipulating space-time. Could we destabilize the universe itself by creating wormholes or time loops? The implications are as vast as they are uncertain. What's next for time travel research? Despite the challenges, research into dark matter is advancing rapidly. Gravitational wave detectors like LIGO and Virgo are helping scientists study the effects of massive cosmic events, like black hole mergers, on space-time. These observations could reveal new insights into how dark matter interacts with gravity. Meanwhile, advancements in quantum physics might one day allow us to directly detect and manipulate dark matter. Every breakthrough brings us closer to understanding its nature and its potential connection to time travel. Could dark matter unlock the mystery of time? The idea of using dark matter for time travel remains speculative. But history has shown us that today's science fiction often becomes tomorrow's science fact. By studying dark matter, we're not just exploring the invisible scaffolding of the universe. We're pushing the boundaries of what's possible. Who knows? Maybe one day we'll discover that the key to time travel has been hidden in the dark all along. What do you think? Could dark matter hold the answer to humanity's ultimate question? Let us know your thoughts in the comments below. And if you're as fascinated by the mysteries of the universe as we are, don't forget to like and subscribe for more cosmic explorations. Until next time, stay curious and keep exploring the unknown.